Okay, good afternoon, everybody. So first of all, can you switch them off? No, only these two. Let them run. Okay. Okay. Yeah. So as we discussed about the quiz number 2, it will be in offline mode only. Okay. So I have sent the form one that you must have received through Google Classroom. I hope every one of you had filled it. This is just to figure out how many don't want to attend. Yeah. So, but we want to conduct it in offline mode only because that's good for you. You know, and for instructor, this online is better, but for students it's not. So it's I think I will go with what is good for you guys. Yeah, and those who wants to give online only, I will see who are on campus and all, and accordingly I will take some decision. But it will be in offline mode only. Okay, in online option will be given, but I will have to see how. Now, the regarding the what we have been studying so far. So we have so far we started chapter number 9. Yeah, and we worked on some 2D elasticity problem where we have fixed somewhere, and then we have applied some forces at some location at the boundary, and then we want to find out how the displacement will be. So we have to find out u x y equal to what, and once you know the displacement, you can find out any other things. When you say u x y, which is a vector field, so we are talking about basically u x as a function of x y and u y as a function of x y. So both of them we are concerned about. Okay. Okay. Now, equations we have already that you know, and our equation so far is divergence of sigma x, okay, plus bx, bx at a function of x, y, that is equal to 0. Second equation is divergence of sigma y, yeah, plus by as a function of xy is equal to 0. Okay, so this is 1, 2, 3. You can write as a combination, both are applicable. 3 we have found out as a combination. Remember, the same thing we write del S transpose of that. Yeah, and then we have D. So, all these are matrix rotation. Then we have del S, then U, right? And plus B, right? Plus B vector is equal to 0. So this number 3 follows from 1 and 2 basically. Yeah. So this is the same equation which implies the second one, third one. So we have that. Then we have, apart from, so these are the equation. Now you have the boundary conditions, right? And what is the boundary conditions? So you have u, right, is equal to u bar Yeah, so let's call u bar only, which is a vector. So u vector is given at, or you can say u not like this. Yeah. So you can also write like this one. So u, which is a vector at gamma u. Yeah. Then we have t, which is given, right? T is given. So t is equal to t naught, right? At gamma. Yeah. So this is a force basically, force per unit area which is given. But since this is 2D, so force per unit length, distributed load basically it's given. So these are the boundary conditions which are given. Okay. Now, if you have this equation, if you want to solve it analytically, how do you do it? How will you solve these equations? If you are asked to solve, did you have any course where you solve these equations?
So you go over a functions or just n1 you won't discuss.
So that is finite element analysis, but I'm talking about the analytical method. It's difficult. You have to study what is known as linear elasticity. This is a full-fledged graduate level course. And if you want to know how to solve, you study this. How to solve analytically. For that, you have to first know, you have to study continuum mechanics first. Once you have met the background of continuum mechanics, then you have to study linear elasticity. Okay. So, lot of things come into picture. After that, this also based on some assumption, you will assume some kind of potential functions. You know, there's some potential functions you assume like in a streamline functions, for example, right? Stream functions, as in fluid dynamics you do. Similarly, here also you have airy functions, potential functions, kind of things. So makes it difficult. Yeah. So you will not even attempt it, okay? Because it goes other direction. Okay? So you need some background before that. So basically, this is it difficult to solve? As simple as that, and hence you will not attempt. Here we want to solve using finite element analysis, which is much easier. You can also computerize. You can solve difficult problem with this method. Okay, now then what? We want to find out how to solve analytically difficult. Yeah, so it's a difficult. Okay, and hence motivation, we will find out approximate solution. And when you say approximate solution, then we will use Galerkin method. Right? We have used Galerkin method. So coming back to Galerkin method, and hence we will find out first the weak formulation. Because once you have the weak formulation, after that you can fit some approximate solution, right? Okay, so in order to find out weak formulation, that's what we will proceed with. So from one, we just multiply. Let us say this equation is a strong form, right? So a strong form is, let's take our first equation, which is this: del sigma x plus dx xy equal to 0. So this is a strong form, and weak form will be this itself here, the way we did for the scalar heat problem is the temperature heat transfer problem. Similarly, you can do E multiplied by Wx, which is function of x and y, and then you have this x plus dx x0, yeah, and then over the whole domain. Equal to 0, right? This is what it will do. It's fine. Okay, and then you do what? That really means this, and then Wx multiplied by divergence of sigma x plus it's fine. It's okay. Or what is this? We have already worked out if something like this given, you will write it as, remember, this will be this dot Wx sigma h e omega minus is okay? Okay, and this is by integration by parts, yeah. So from here, this you got these two, or apply divergence theorem, and then you get what? This is what? Divergence of this will be contour integral over gamma, and you have Wx sigma x dot n, right? Minus gradient of Wx multiplied by sigma x t omega plus Wx dx t omega. Any questions so far? Fine. Okay. Okay, and now what is this? Sigma x dot n. What is that? So here only where sigma x dot n is equal to
sigma x and x.
remember tau n is equal to p, right? Or remember what was this? This was sigma xx, sigma xy, sigma xy, sigma yy multiplied y, n x, n y, is equal to Tx Ty. Sigma xx is equal to, this is equal to what? Sigma x is sigma xxi plus sigma xyj dot nxi plus nyj is equal to sigma xx nx plus sigma xy ny. Sigma xx nx plus sigma xy ny is equal to dx. Yeah? Or what we get final w x dx d gamma, guys, d gamma minus gradient of wx dot sigma x d omega plus wx dx d omega is equal to 0. Okay? And similarly, wy in y direction, wy ty d gamma minus fine. Add both of them. And then what you get? You have wx dx plus wy ty d gamma minus minus okay. Any question so far? Take the first term. You have wx dx plus wy dy Either you write it as Wx I plus Wij dot Txi plus Tyj is equal to, you say W vector dot T vector. Either you write like that or you write it like W, right? And then you have T, where W is equal to Wx, Wy, and T is equal to Tx, Ty. But yeah. Now this was number one, number two term from here. Okay, let's take a number three. Is it number three? Bx, Wx, similarly Wx, Bx plus Wy dy, again Wx I plus Wyj dot Bxi plus Byj is equal to W dot V is equal to W transpose B, where W given like above and B will be is Bx. Number two. Yeah. Number two term, we have L, the gradient of Wx dot sigma x plus gradient of Wy okay, which is equal to, now we can spell it out. Yeah, and what is this one? This one is nothing but del Wh over del xi plus del Wy over, sorry, x1, right? Del y j dot, what is this? Sigma xxi plus sigma xyj, right? Plus we have del Wy over xi del Wy over yj, right? Dot sigma xyi plus sigma yyj. And what if find out from that? We get sigma, del Wx over del x, sigma xx plus del Wx over del y, sigma xy plus del Wy over del x, sigma xy plus del Wy over del y, sigma yy, right, is equal to del Wx over, we can also write this in terms of like this, del x and sigma xx plus, write it here, so del Wy over del y, sigma yy plus del Wx over del y plus del Wy over del x, sigma xy. Right? Is equal to del w over del x wx del wy del y del wx over del y plus del wy over del x sigma x sigma y1 sigma. What did you call this one? Sigma 2. Sigma 2, right? Which is equal to, you call it, first is this term. Okay, so what is that? Now, where, let's say this term is equal to, so del wx over del x, del wy over del y, del wx over del y plus del wy over del x is equal to del over del x, del over del y, 0 del over del y, right? And then del over del y, del over del x. Transpose of that. Maybe we write transpose to begin with, otherwise it will be confusing. So is equal to del over del x, 0 del over del y, 0 del over del y, del over del x. Will it work this way? Yeah? Yes. Okay. So we have 2 by 3. No, it will not work this way. Earlier was better. Yeah, I think. It's 2 by 3, na? See, we have 3, so it will not work like that. So just a minute. We have 3 by 2. Not work. So let me write like this. We have write like this. Del wx over del x, del wy. Huh? Yeah. No, that also we can do, but let's write in this form. This is the del. This is equal to this is equal to basically how we write like this. Right here we have something here, then we have this is 3 by 1. So we have 3 by 2.
2 by 1.
2 by 1, yeah. Wx, so 3 by 2, 2 by 1, they are like this. And then you have del over del x, 0, 0, over y, del over del y, del over. Yep. Or this is nothing but we will write it. We have introduced del s, we call it del s to the okay. So that part we know now. Now okay. Now this term is this. Then we have this sigma term. So sigma, this we call it sigma xx, sigma yy, sigma xy. We call it sigma LD, which is equal to, you remember, d LD. Yeah. Okay. Where d epsilon is what?
Yes, you. Yes, you.
Yes. So coming back to here, that tells us divergence of Wx, gradient of Wx dot sigma x plus is equal to this term. This term is nothing but transpose of that. So we get delta S right? Transpose of that, and then you have this B okay. Just see how beautiful is it. So our weak form becomes what? If you sum them together, and from 1 you have W transpose T minus then you have this plus
Transpose sign should not be there inside the bracket, right?
say again
So that delta S transpose, that should not be transpose.
see the final form. Like you also had earlier in 1D, you remember you had W multiplied by F. Right? So here also a force term is coming. Here you have gradient of derivative of W coming here, multiplied by some E you had, which is D matrix here. Then differential of U, you have derivative of U. So that's E is here. And then W multiplied by V you have. The same thing is coming here. Only thing is it is vector now. That's the only thing. Of course, when you say this equation is the weak formulation, you have to define U, define W and all, right? Where U is, you have to write as per the boundary condition, where U, in this case, this U is equal to Ux and Uy, right? And which is equal to Ux bar and Uy bar at gamma U. So U has to satisfy that boundary condition. Yeah, even if it is a test function, even if it is an approximate solution, it has to satisfy the boundary condition. Where W is, you write this one, and you also write this statement is, you have to write for all W's, right? With what? W equal to Wx, Wy is equal to 0, 0 at where U is defined, W is going to be 0. And that's why we give that condition as well. Yeah. Any questions so far? Once you reach here, the rest is assuming the fitness or not fitness, but the test function and accordingly solve it. And you follow the same old method, nothing new in this case. So how to solve the problem? It comes back to the same kind of, let us say you have the domain like this, where the fix, there is a somewhere force applied here. Yeah, this is T which is given, and this is U which is given, right? So U bar equal to U, let us say T bar is some value given. Yeah, is equal to T dot N is equal to T naught, which is given, right? So all vector basically we're talking about, right? Okay, so this is when you have things which are given like this, then what do you have? Not this will be T sigma. Sigma in terms of, so we don't write T dot N, so sigma dot N basically. So we just write T. Then you understand what T is. So T is equal to T naught. Okay. Then how do you do that? How do you solve? You either discretize it as a triangular element. Yeah. Something like this you do. Yeah. And then you do the analysis. Triangular element, or you can have a 3-noded triangular element, or you can have 6-noded, or you can have a quadrilateral element, or you can have many other kinds. You can have 4, 5 noded, or you can have 8 noded, and so on. Yeah. Depending on what kind of solution you want. Everything all right, guys? Yeah. So now let's solve it for a small problem. Let us say you have a triangle, right? On that problem could be something like this. This is a triangle like this, and there is a force like this one, or maybe force here, like this one, right? You can have a force like this, where you have A, B, C. AC there at the U is given equal to 0. Then we have a T defined on this S, and then we have to find out the displacement. Yeah. So in that case, how will you find it? First, we have to, if this is the domain, and what you have, these are the gammas. This will be this is gamma T, where you have T bar at 0. Let us say this is T bar, and this is gamma. Let's say gamma T1. This is gamma T2. Gamma T2, where T is equal to T bar, and here you have gamma U, where U is equal to C. So those things are given. Only thing is how you are going to formulate it. If you want to take it just 3 node, solve it. Today we just look at the process, and this is same as what you studied in heat transfer or heat transfer problem. Let's say this is 1, 2, and 3, and then you have N1, N2, N3. So N1 is equal to, let's say you have at this point you have X, Y, and N1 is equal to A1 over A. Same kind of thing will appear here also. A2 over A, N3 is equal to A3 over A, where A, as you know, here will be X1, Y1, X2, Y2, X3, Y3. Right? For triangular, it will be like this. In general, how do you write? In general, let's say in general you have n, you have a function, shape functions, and you write u is equal to shape function ni multiplied by ui vector, right? And I is equal to 1 to number of nodes. Yeah, n is equal to number of nodes. So in general, we are writing like that. Yeah, or you can also write is equal. What really means I equal to 1 to n. Then you have ni, which is a function of x, y, multiplied by ux, uy, right? But we have ux Let's say this is ith one, this is ith. That's what I'm talking about. Right? Either you write I there or you write I here. Maybe after x we can write. Right? All right. Okay. Once you have that, then what is the next thing to do? We have u, x defined within this domain. U as a function x, y is defined like that. Where what we mean by u, x, I and all, that really means that you have a triangle and displacement here in this direction is ux1. In this direction is number 1 more. This direction you have uy1, ux2, uy2, ux3, uy3. So these are the displacements, and you are writing displacement inside it as a function of this displacement, and how they are related through the shape function, as you have done earlier. So it is not different from what we have studied earlier. Now, only thing is we have to find out this value. This is what this we are writing as a vector form. So in like this one, or this one is basically our u1. So u equal to n I x y and u x I u y I. Yeah, so I'm not distinguishing between vector form and the matrix form, but you understand what I mean. So this is I equal to 1 to n, right, like that. So here, this is nothing but what I want to say is u tilde is equal to ux y, which is like this. Now we have to put this. Only regardless of what kind of element we are talking about, if it is a triangular element, 3-noded triangular element, we will have n equal to 3. If you have a quadrilateral element, 4-noded, you will have n equal to 4. So in general, we are talking about. So now del S U, which is what? Epsilon, right? Which is epsilon. And finally, this is the one you have in the equation also, right? So you have here this term, right? So this term is which is nothing but epsilon only, which is nothing but epsilon xx, epsilon xy, yy, epsilon xy is equal to this, is equal to, and then this one. Then you have I equal to 1 to n, ni xy, and then you have this uxi uyi. What happens if you have this? Then what happens? So see here. So far, we are going to write like what? We are going to write here the same thing. This one we write as S is equal to del S, and then you have N1, N2, zero, N2, 0, N3, 0, and so on, right? You have N0, 0, N1, 0, N2, 0, N3, 0, N, and then you have what do you have? U x1, u y1, u x2, u y2, u xn, u yn. Yeah. Or this you also call n vector. So Sn n matrix, and this let's call it D matrix. Yeah. So this is the displacement, which is the given displacement matrix. Okay, so to distinguish from U, we call U something else. So this is our D. So this is D vector, and this one is N. This one is N. Now is equal to, what is this? This one is let's call this thing equal to B. Yeah, where B is equal to yeah, which is equal to what? This one is what? What is the size of this? 3 by 2. 3 by 2. Now what is the size of this? 2 by 2. Okay. So now this is del over del x, 0, 0, del over del y, del over del y, del over del x, and multiplied by this. N1, 0, N2, 0, and so on, 0, N1, 0, N2, and so on, is equal to, if you multiply this, so what you get? You get del N1 over del x, right? Here, this will be, if you multiply this by this, you get 0, multiply with this, you get del N1 over del y, right? Then this by this, you get 0, del N1 over del y, del N1 over del x. Yeah, and so on. We will have del N2 over del x, 0, del N2 over del y, 0, del N2 over del y, del N2 over del x, and so on. At the end, you will have del N over del x, 0, 0, del del n over del y, del n del y, del n del y. This is what the V matrix is. Okay? Fine. So finally, the original equation that we wrote, remember del S W transpose of that D, then what you have here? Del S U. This becomes equal to, we'll find out what that is. Del S W, then you have D, and this one, this one is nothing but B. Right? You have B, and then this D. Right? Fine. So far we got like that one. Similarly, you can work on this one. Similarly, just like you had you defined U, you can define as W as well. Right? Just give me 2 minutes, we'll finish it. Okay, so similarly, W will be equal to, in the same way, just replace U with W, and what you will find that this W is equal to Wx pi summation of Ni times Wx I Wy, right? I equal to 1 n. In similar fashion, we can write, right? And so this Ws will be equal to, if you do the analysis, you will get the similar way, V times, right? And then we have, instead of W, we call it, let's call it V, right? Let's write as V, where this is equal to W x1, W x2, so W y1, W x2, W y2, so on to W n, W x n, W y. Yeah. So this will be, okay, this is transpose. This will be equal to what? This will be equal to V transpose B transpose D transpose B and D. Yeah. In heat transfer also you got V dP. Remember? K equal to integral of V dP. Same thing we are getting. Here, pre multiplied by the weight, post multiplied by displacement. Right? And this will give us K basically will be expanded. That we will do next class. So this one from here we will continue. Okay. Any question? Little bit longer I took, but we had to finish. Otherwise, we had to start in the beginning. Okay. Okay, guys. Any question? If
Can we discuss anything small related to three-dimensional? Like finding shape functions.
yeah, we can see it, but in this class probably. Uh,
On 26.
on Wednesday we have tutorial. We'll do Wednesday. See, if you want extra thing, you can discuss it. It's given in the book also. Why don't you do it? Just see, just to try yourself. Just don't. I mean, the idea is based on what you have learned, you should be able to extend. Don't let all the things done by instructor, and you are just enjoying the entertainment. I mean, the torture. It should not be like that. You try it first, and if you see if you are facing a problem, then you talk to me. So you just try. In fact, this is a part of the tutorial problem also. If you see, right? It says that extend to 3. Okay, see you on Wednesday, guys.